Okay, so members, today we are going to see another intersection of circles. Now, the circles can intersect, we have seen they can intersect through a common chord. Now we have seen orthogonal circles. Now we are going to see circles that intersect internally and externally. Now, if I have this circle with radius capital R, and I have this one with radius small r, this one is having center 1, this one is having center as 2. The distance between their centers, this distance between this and this center, we see is the sum of this radius plus the sum of this. We having the distance between their centers, and if this condition is true, that the distance between their centers is the sum of their radii, it means that those circles intersect externally. Now, if they intersect internally, it's that this one, the intersection is here for the two circles. This one is having the big R, this one is having the small r. So the distance between their centers, so that I will get the big from here up to here, then minus from here up to here, I will be getting the remaining distance big. So if they intersect internally, then the distance between their centers is the difference of their radii, where d is the distance between the centers. Even here is the distance between the centers. Let us see how do we handle those numbers. Find whether the following circles intersect externally or internally. All we do, we need to get their centers and their radii. So from here, let me get this center. If I compare, it's negative 2a, is negative 6, and negative 2b is negative 2. And so from there, my a is 3, then my b is a 1. So this center 1, comma 1. So start also with the radius. Let me call this capital radius. It's going to be the square root. We say you get 3 square, then plus 1 square, then minus c. So from there, our c, if you compare this and this, our c is 1. So then minus the c, which is 1. So that now my radius from here, I have this as 1 minus 1, which is, so that my radius is 3. When I come to this, so if I compare, so negative 2a, then negative 2b, negative 8. And start from here, our c is 13. From here, my a is negative 1, my b is 4. So to get down the center, the second center, comma 4, and my radius is going to be the square root of negative 1 squared, then plus 4 squared, then minus. So that one is going to give us 13. So this would be 17 minus 13. That would be 4. Square root of 4. Our radius here is 2. Now I want to check. So that when I sum the distance, now we are missing now the distance between these centers. So my distance is going to be the square root of, now I say 3 minus 1, the whole square, then plus this minus this, the whole square, and this is there. So our distance would be, this will be 16 plus 9, this is 25, square root of 25 is 5. And you see that now if you add these ones, you get this. So from there, so that your d is equal to capital R plus small r, which is 3 plus 2, which would be 5. Meaning that if this condition is satisfied, now these circles intersect externally. Why externally? Because it says if you add the two radii and you see the distance between their centers, then they intersect externally. When I come to this, still if I compare with the general equation of a circle, you see from here, negative 2a is negative 6, negative 2b, negative 2. Here my a is, here is 5, and you see that our c is negative 2. So our center 1 is 3, 5. Then our big radius, let us see how we get. We get this squared plus 10, 5 squared, then minus, plus 5 squared, then minus, you see that one say minus now 2. So that this radius is going to be 25 plus 9, that's 34, plus 2, 36, square root of 36, you get 2 units, I mean 6 units. When I come to this table, I compare negative 2a will be 2, and negative 2b will be negative 4. And compare it with this. So that our C is going to be 4. From here, I see that my A is negative 1, my B is at 2. So my second center, negative 1, 2, and I come and I get my radius, the other radius, which will be then minus a 4. And now this radius is going to be 4 minus 4, it's going to be 1. Then I need to get also the distance between their centers, will be the square root of 3 minus square then plus 5 minus a 2 all square. And this will give me 5 units. So my B is 5. Now you see that I need to check. So that my B will be now, let me say, if I am, is it R plus R or B is R minus R? You see, if we add them, we shall be getting 7, which is not the case. So this one can't work. When you come now to this, you see that your B will be R minus R, it should be. Here the R is 6, then the other radius is 1, which is equal to 5, which is the distance here. Meaning that now my B is R minus 1, meaning these circles intersect internally. So remember, that's the difference between circles intersecting internally and circles intersecting externally. Don't forget to subscribe to the channel. I wish you the best. Next week we are going to cover conic section.